Kia ora koutou. I haven't videoed last year's exam papers yet and decided it was time I did that. So here's question 1A from the probability exam. I think it's a really great question that goes over tree diagrams pretty thoroughly. So I'm going to start with this one. So it's all about electric vehicle ownership and a survey that was done on staff and students at New Zealand University. Really important that when you're doing probability questions that you read that introductory context carefully and that you answer in context. So owning an EV in New Zealand has got more popular is that technology has improved. Prices have dropped and people have become more aware of environmental issues. Yep. Okay, so the questions in this whole paper are about research about electric vehicles. This is just question 1A. So Tia finds the results of a survey conducted on staff and students of a New Zealand university. Straight away, we can see that they're probably going to be our two groups. And the survey asked about things related to ownership of EVs. So 15% of the survey respondents were staff and the rest were students. Then we've got 90% of the staff and 43% of the students drove to uni. So straight away you should be thinking, I'm going to do this with a tree diagram, okay? Because a table is going to be messy. And then in the next bit, that's confirmed because we're given the number or the percentage of the students who said they wanted to own an EV. And then 60% of the students who didn't drive said they'd like to own an EV. So we've got three things going on in here. We've got the staff, students, then we've got did they drive or not drive, which I'll do as D or not D, and then we've got do they want to own an EV, and I'll put EV for that, or do they not want to own an EV dash. Remember that dash means the complement, in other words, the not event. So the first two questions are pretty straightforward from the tree. Find the probability that a randomly chosen respondent in the survey is a staff member who drove to the university. And then the second one, I'll do at the same time, find the probability that a randomly chosen respondent is a student who didn't drive and would not like to own an EV. And then the next two are a little bit harder, but I'm going to start off with these and get those done first. So we're going to start by drawing our tree diagram. So the first bit on the tree is we're going to have staff or students. And then after that, we're going to put on drive or not drive for each. So that's going to be D and not D. And we'll get those percentages on first. So let's go back and have a look. We can see 15% were staff and 90% of them drove. So it's 15% here, which means that down here must be 0.85 because they have to add to 1. And then 90% of the staff did drive. That means the other 10% didn't. And for the students, if you look back up, it was 0.43 drove, which means the other 0.57 didn't drive. And then the EV information has to just go on the student information at this stage, right? Because we're told of the students who drove, 36% said they'd like to own an electric vehicle. So we've got to have new branches here just for the students. So it's going to go like this. So it's a tree with lots of tree bits, also called branches, right? So we've got EV here, didn't want an EV here, EV here, and didn't want an EV here. So we're going to have 0.36, 0.64, 0.6, and 0.4. So these first two questions are simple ones where we just have to multiply along, right? We want a staff member who drove to the university. So that's this branch here, staff member, and they drove. So probability of staff and drove is equal to 0.15 times 0.9, which I think gives us 0.135, right? That's not surprisingly just a little achieved question. The second one is also achieved. It's got 3 bits in it. So we've got student, probably student, and that's my symbol for and they didn't drive, and they don't want an electric vehicle. So it's 0.85 times 0.57 times 0.4, and that equals 0.1938. Okay, now just moving back, I've just got to move my screen, it's just vanished. Moving back to the start of that question, The next two bits are harder questions, right? So in the next bit, we've got to read it carefully for what they're asking us. If a student respondent said they wanted to own an EV, what's the probability that they drove to the university? So this question is actually not that hard, but the only people we care about here are the students. So the way that I did this is I thought about my tree, and I just don't care about all of the staff bit, right? So I'm sort of thinking of just this part of the tree, right? So out of the students, if they said they wanted to own an EV, what's the probability that they drove to the university? Okay, so let's write that out. So the probability, this is just for the students, right? So the probability that if they said they wanted an EV, that they drove. So we're working just with this bit of the tree, but we're working with a backwards conditional probability. So how do we do that? Well, I've done that in another video, but what we're saying is how many of them, or what probability was there that they both drove and wanted an EV out of the ones who wanted an EV. So remember, the definition of a conditional probability is this: the probability of A given B is the probability of both those things happening divided by the probability of B. And now once you've written that definition out, it's pretty easy if you've done your basic work on tree diagrams. So the probability of a student driving and wanting an electric vehicle is this one here, drive and EV. So that's going to be in my numerator. So that's 0.43 times 0.36. Now, what's the probability that a student wants an EV? Well, there are two things that go into that one. There's this one here that they drove and wanted an EV, and this one here that they didn't drive and they wanted an EV. So there are two outcomes making up that probability, and they both have to go into my numerator. So it's 0.43 times 0.36 for drove and wanted an EV, and then 0.57 times 0.6 for the ones who didn't drive and still wanted an EV. So when you work those numbers through, we get 0.1548 divided by 0.1548 plus 0.3420. And very stupidly, I can't remember what that works out to. But you can put that in your calculator and you can get that number there. And that's the answer. Okay, so I'm sorry about that. Don't stop here because you won't get the full marks, right? So you need to go to this step here. I have failed you. I haven't done that. Never mind. Right, okay, on to part 4. I'm not going to redo the whole video because of that. So the next one is, I have done the whole thing, is actually easier than that question 3, right? And what they're giving us here is they're finally giving us the last bit of the tree. So now we're getting told, out of the staff who drove to the university, 52% said they'd like to own an EV. So we're going to go and put that on our tree. And then only a quarter who didn't drive said they'd like to own an EV. So we're going to complete that, and then we're going to find a pretty simple probability using the last bit of tree. So now we're going to have EV, not EV, EV, not EV. So here it's going to be 52% of those who drove, right? So that's that bit there. Want an EV, that means that this must be 0.48. And here, only a quarter of those who didn't drive would like to own an EV. And 0.75 of those who didn't drive didn't want to own an EV. So notice I'm getting these because they have to add up to 1. Now, finally, we just have to answer what percentage of all the survey respondents would like to own an EV. So to do this, we just have to quite systematically work through that tree and figure out all the bits that are there. Right now, the drums have just started up downstairs from me, so I'm going to make this fast. So let's just highlight which ones they are. So who wants to own an EV? Well, there's going to be 4 groups, right? We're going to have the staff who drove. We're going to have the staff who didn't drive who'd like one, the students who drove, and then the students who didn't drive who'd like one. So we need to add up those 4 probabilities. So we just want to make sure we list them out carefully. Right, so the probability that someone wants to own EV has got these four things in it, right? So 0.15 times 0.9 times 0.52, and some of you in my class will have done these at the end of the tree, so that's fine, plus 0.5 times 0.1 times 0.25 plus 0.85 times 0.43 times 0.36 plus 0.85 times 0.57 times 0.6. And when you add all of those up, so the numbers individually that you get there are 0.0702 plus 0.00375, boring, 0.013158 plus 0.2907, and all of that adds up to give us our final answer of 0.4962. Now that was a merit question, so you can see in this video already, even in 10 minutes, we've done 2 achieved questions and 2 merit questions. So if you're feeling like, you know, there's a lot to learn in this probability standard, I think you'll find that once you start to master the trees, the tables, the normal and the relative risk, you've got a fair bit of it down. So email me if you've got questions. I'll do the other questions later on this weekend.